Hello again, and welcome to our second section of our statistics chapter. In this section, we're going to be talking about distributions of data. So in the past, you've calculated measures of central tendency, that's mean, median, and mode. And you've calculated variation, which also includes standard deviation, which we'll review briefly. So what we're going to do today is use the shapes of distributions to select appropriate statistics. So based on how my data is shaped, we're going to know if we should calculate the mean and the median, if we should calculate standard deviation, range, what we should do. And we're going to use shapes to compare different data sets and be able to say some things about them. So the new vocabulary you should be on the lookout for is here. Make sure as you go through that at the end of this lesson you can explain what all of these are. Okay? Part 1 of this section is analyzing distributions. Basically what a distribution is it shows the observed frequency or the theoretical frequency of each possible data value. What does that mean? It shows how many times I could get each kind of result. So that's my distribution, and you'll see what those look like in a bit. A lot of times we use histograms to show those, kind of like a bar graph. In past years, we've used mean and median to describe the center of our data, and we've used quartiles and standard deviation to describe the spread. Center means that we're kind of using one number to describe what the data is. We'll talk about that in just a second. And spread is how far spread out or how clustered together is my data. Analyzing the shape will help me decide if I should do mean or median, if I should do standard deviation or quartiles. So just a reminder of what a measure of center is, or also called a measure of central tendency. It is one value that attempts to describe a set of data by identifying the central position. So it's basically one number that we're using to sum up or summarize a data set. It's like a typical value. 3 ways that you guys have measured center or central tendency before this is mean, median, and mode. This is a review of what those are. Remember that mean is adding up all the values and dividing by how many they are. The median is the middle value. And then the mode is the number that appears the most times. So we will be focusing on mean and median mostly in this section. We won't be using mode very often, but you should know what it is. A reminder of what standard deviation is. This is something you have calculated before. If you don't remember how to calculate it, step 1, you find the mean, which is just the simple average. Then for each number in the set, you subtract the mean and square it. Then you're going to get a whole bunch of results here, right? One for each number. You're going to find the mean of those squared numbers. So I'm going to find the average again. And then I take the square root of that, and that's the standard deviation. We're going to be using our calculators a lot to get this, but you need to know how to calculate it as well. Another kind of statistics that we're going to deal with is the 5-number summary. It might have been a while since you've done this, but we did do this in Algebra 1. The 5-number summary includes the minimum value, the median value, and the maximum value. Then we also have quartiles. The first quartile is halfway between the minimum and the median. And the third quartile is halfway between the median and the maximum. We use the 5-number summary to construct box and whisker plots or box plots. Okay, these 5 numbers divide my data into 4 groups. Those 4 groups are equal in size. Each group contains 1/4 of my data. All right, so when I make a distribution, right, and here they're showing you what a distribution could look like. It usually, again, looks like a histogram for right now. I can have distributions that are symmetric, meaning that the mean and the median are about the same, and it goes down the same amount on both sides. The data are evenly distributed on both sides of the mean, so it's about 50% on both sides if it's symmetric. I can have a positively skewed distribution. Notice that my tail is toward the positive side. We name this by where the tail is because it means I have some outliers or a few data values out here on the positive side that are dragging my data to the right, to the positive side. That's why it's called positively skewed. When it's positively skewed, the mean is greater than the median. Okay, so it makes the mean higher than the median is. But the majority of the data are to the left of the mean. But these few higher values up here make my mean larger. So in this case, the median is actually a better value measure of center because it's more in the middle of what the data actually is. A negatively skewed distribution has some negative values that pull a tail on my distribution off to the left. So it pulls my data to the left. It pulls my mean to the left as well. So in a negatively skewed distribution, my mean moves to the left because of these few values out here, but the median still kind of stays in the middle. The majority of the data are over here to the right of the mean. So again, that makes the median a better representation of the center of my data. All right, so depending on if my distribution is symmetric or skewed, tells me what kind of statistics I could choose. Remember, one of our goals for this section is choosing appropriate statistics. So when my distribution is symmetric, I can just find the mean and the standard deviation, and those will accurately reflect the center or a typical value and the spread or how far spread out my data is. When my distribution is skewed, the outliers that are making those tails to the left or the right really affect the mean. Okay, so the mean changes a lot based on outliers, and it moves it away from the majority of the data and it moves it towards the tail. So the median, which is less affected by the outliers, because the median is still the middle number no matter what, stays nearer to the majority of the data. Okay, so when a distribution is skewed, I usually am going to use median and not the mean. So when I'm choosing appropriate statistics, if it's symmetric, we use the mean and the standard deviation. If it's a skewed distribution, meaning there's some outliers, we use the 5-number summary. And so we'll look at a box and whisker plot. All right, so let's take a look at this example. And here we're going to describe a distribution using a histogram. So Mr. Schroyer's students each gave a presentation as part of their class project, and here in this table we have the length of each presentation. So we're going to be using a graphing calculator to create a histogram. Then we're going to describe the shape of the distribution, okay? We'll focus a little bit more on the graphing calculator part in class. I'll give you instructions on how to do it with the Inspire. But when you get your histogram, it will look something like this, okay? So here's the histogram that they got from their graphing calculator. So you can see that the majority of my data are on the right-hand side. So my distribution is negatively skewed, right? My tail is coming off to the left or to the negative side, so we call that a negatively skewed distribution. All right, part B, we're going to describe the center and spread of the data, and I have to choose whether I'm going to use mean and standard deviation or 5-number summary. Well, going back to what we said on a previous slide, since the data here is skewed, and again, tomorrow in our graphing calculators, we'll get our 5-number summaries a little bit easier with that. But the range, the data is skewed, so we're going to use the 5-number summary, which means that we're going to have our minimum and maximum values. We're going to have our median. Let me just write this out for you. Our minimum value is 7. Our maximum value is 23, if you look back at the chart. The median, or the middle number, if I wrote them all out from least to greatest, is 17. So the first quartile is halfway between 7 and 17. 13, that's the data point that's halfway between there. And quartile 3 would be 19.5. So this is the 5-number summary. The total range is from 7 to 23. The median is 17 minutes, right? And then half of my data, remember there's 25% between each of these numbers. So half of my data is here between 13 and 19.5. 50% of my data is right here. And all they're asking me here is to describe what's happening, right? So this is just a description of the range from 7 to 23. The median is 17. Half of my presentations were between 13 and 19.5 minutes. All right, here's another example. You guys try this one. In this case, the mean and the standard deviation are better because this is a symmetric distribution. On Google Classroom, I left you a histogram generator, so hopefully you could use that since you don't have the calculators right now. to find a histogram, and you would have been able to look at that to decide to find the mean and the standard deviation. All right, now we're going to talk a little bit more about box and whisker plots. You guys have done these before. They help us identify the shape of a distribution as well. If we decide not to use a histogram, we can use a box and whisker plot. Remember that this line in the middle of the box and whisker plot represents the median. So if the median, that indicates kind of the middle of the data, right? And the whiskers show how spread out it is. If one whisker is longer than another one, and the median is close to the shorter whisker, it's like having a skewed distribution. So here in this first picture, we have a negatively skewed distribution because remember, half of the data is to the right and half is to the left. But my left-hand data is stretched out, so that's like thinking about the tail in the histogram pictures we looked at. So this is negatively skewed. This would be a symmetric distribution, and this one would be positively skewed, again, because the stretched out part of the data is over here. Remember that no matter how long it is, 1/4 of my data is in each of these sections, right? So just because it's smaller doesn't mean there's less data. 1/4 of my data is in each section. This one is just stretched out, which is what makes it positively skewed. All right, so let's take a look at this example. So again, on Google Classroom, I posted a box and whisker plot generator. I'll be showing you how to do these on the TI Inspires in class. But we're going to make a box and whisker plot. Here they're going to show us how to do it on a different kind of calculator, but it looks like this. So if you compare it to the chart in your notes, this is a positively skewed box and whisker plot, because remember 1/4 of the data is in each section, but here my data to the right are stretched out. The right-hand whisker is longer, and the median is close to the shorter whisker, so this is a positively skewed distribution. Part B is asking us to describe, again, the center and the spread. So I need to decide if I'm going to use the mean and the standard deviation or a 5-number summary. Since this is a skewed distribution, I'm going to use the 5-number summary. So when I get my 5-number summary, which I'll also show you how to do on the calculator tomorrow with bigger data sets, sometimes that's easier. My minimum is $6.50, my maximum is $11.25, and my median is $7.88. Quartile 3 is halfway between $7.88 and $11.25. It's the data point halfway between there, right? I'm not just averaging these two, I'm actually looking at the data. And then quartile 1 is the data point halfway between the minimum and the median. So we know that half of our data is here between quartile 1 and quartile 3. 25% of it is below quartile 1 and 25% is above. My range is from $6.50 to $11.25, and my median is $7.88. Okay? So you guys try this one. They're asking you to describe the center and spread. To do that, you'll either have to make a histogram or a box and whisker plot using the things that I left you on Google Classroom for this assignment. And then get the 5-number summary or the mean and standard deviation and justify your choice. If you're not sure how to get those, remember I have it listed for you on your handout if you don't remember how to do mean or standard deviation, for example. All right, in this case, it was again a skewed distribution, so you should have done the 5-number summary. Your minimum was 0, your maximum was 12, your median was 3, and then quartile 1 was 1, and quartile 3 was 7. All right, I think we're going to leave this next part for our second video. So that's the end of the first part of this section, and I will see you in class to practice.